students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the chapter number 1, electric charges and fields of class 12 physics CBSE NCERT. So let us start with the topic Coulomb's torsion balance experiment and the Coulomb's law. Coulomb's law is very much important. So for that, Charles-Augustin de Coulomb, he experimented, he discovered this setup. He did not invent it, but discovered this setup, and that eventually led to the Coulomb's law. He discovered, he experimented, and he made a conclusion. That conclusion today is all famous as Coulomb's law. Okay. So the setup is shown over here. In his setup, there was a cylindrical glass case. Glass case was there, which was having a lid, which the lid was having a hole, as well as the lid was attached to a glass tube. Okay, the glass tube was having a covering which is known as torsion head, which is known as torsion head, and the thread was suspended through the glass tube. That thread was known as torsion fiber, and the thread was usually silk thread. Okay, that is silk thread. So that was suspended through the glass tube. That thread was connected with a knob or a screw over here. Over here was a knob or a screw, and which was connected with a needle, horizontal needle. Also, there was a scale, horizontal scale over here, which was depicting the scale, which readings over here, which was having the readings, and the horizontal needle was having a metal ball disc at one end and a spear at another end. Okay, and some spear at another end. Okay, this spear is just for the balancing. It is just for the balancing. Okay, so the hole was placed over here, and from this hole a metal spear was dropped inside. A metal spear was dropped inside. Okay, but right now this spear was not having any charge. So the spear was not having any charge, so there was no repulsion. This metal ball disc was having positive charge already, so there was no repulsion right now, because this spear was not having any charge, and because there was no repulsion, so there was no movement in the thread. There was no twisting, no movement in the thread. Then what he did, Coulomb what he did, he took out the spear and he brought that spear in contact with the positive charge. He brought in contact with the positive charge, and then again he placed the spear through the hole, and this time, because this was also positive, so both the positive charges repelled. So there was a repulsion force over here acting, and due to that repulsion force, the thread got moved. It got twisted, and when the thread got twisted, there was a repulsion, there was a displacement in this needle, and that could be easily seen. That displacement could be easily seen through the scale. So now let us say our needle moved in this direction. Okay, and the displacement could be easily seen. Now what he did, he again took out the spear and he brought in contact with a spear of the same size. And so what happened, this spear reduced its charge to half. It reduced its charge to half the value, and reduced charge value to half. Okay, and again placed through the hole, and again placed through the hole. So now this time he observed that the repulsion force was less. He observed the repulsion force was less, and also the needle movement was less. So he observed these all things while experimenting through this setup. So he was a French engineer, and he was had very much keen interest in electricity and magnetism areas. So he observed that whenever the charge value changed, the repulsion force also changed. So he observed that it led to the conclusion to him that the force which was acting through the static charges, the force that was acting through the static charges moved through an angle, and that angle depended upon the twisting of this thread. It was depending upon the twisting of the silk thread. Okay. So he eventually led to the conclusion. He carried out this experiment through many magnitude of charges, changing the magnitudes of the charges, and he also calculated experimentally the ratio between the force and the charge. He was also very much keen to observe what is the ratio between the force and the charge. Okay, so because of this whole experiment, he eventually led to conclusion that the force between the two static charges, they attract or repel by the charge value, the force which is exerting the attraction or repulsion between the two charges. So if there are two charges, we can see over here like this, if there are two charges, the charge is Q1, let us say this is Q1, let us say this charge is Q2. So they will be attracting or repelling through some force, and that force these will be attracting or these will be repelling through a force, and that force will be directly proportional to the magnitude, product of the magnitude. That would be directly proportional to the product of the magnitude, and okay, it can be any charge, and it would be inversely proportional to the distance between them. Let the distance between them be r. And it would be inversely proportional to the square of the distance between them. So combining these two, F will be directly proportional to Q1 Q2 upon r square. Okay, if we will remove the proportionality sign, we will be getting over here F is equals to K Q1 Q2 upon r square, and this K is known as proportionality constant. It is known as proportionality constant, and the value of K is given by 1 upon 4 pi epsilon naught. It is the permittivity of free space. Okay, so this is denoted by naught, and it is the permittivity of free space. Okay, it is the permittivity of free space. Okay, and the value of epsilon naught is given by 8.854 into 10 power minus 12 farad per meter. Okay, also the value of K is given by, it is a proportionality constant. It is a proportionality constant because we are removing the proportionality sign from here. So constant to be placed, that constant is known as proportionality constant, and the value is given by 9 into 10 power 9. This value is very much important for the numericals point of view. Okay, and this value is also very much important. You can directly place the values and you can directly get the numerical values, whatever the values are, either for force, charge, or the distance. Okay, So this is all the Coulomb's law. This is only the Coulomb's law. The Coulomb's law states that the force between two static charges, either they may be having the attractive forces or repulsive forces. The magnitude of that force is directly proportional to the product of the magnitude of the charges, and inversely proportional to the distance between those two charges, So this forms my Coulomb's law. So through this setup, Charles-Augustin de Coulomb was the only one scientist and the French engineer to derive this Coulomb's law and demonstrate through an experiment. So this is all about the experiment. So thank you. So please subscribe my channel. Please share my videos. And if you have any doubt, you can ask me in the comment section. Thank you.